The center of gravity of a body is that point at which the entire weight of a body or the force of gravity can be supposed to act upon. For symmetrical bodies, the CG is at the geometrical center. Let us consider an irregular shaped lamina. The force of gravity acts on all the particles of the body. Let us try to locate its center of gravity. We try to balance the lamina on the tip of a pencil. By trial and error, we can locate a point G on the lamina, where it gets balanced. This point of balance G is known as the center of gravity of the lamina. The tip of the pencil at G provides the reaction R to the total weight mg of the lamina in the upward direction. The lamina is in translational equilibrium as R is equal to mg. The lamina is also in rotational equilibrium, otherwise it would tilt and fall. Thus, G is the center of gravity of the lamina. There is yet another exact and easy method to determine the center of gravity of an irregular shaped body. Let the lamina be pivoted at 3 different points A, B, and C. Hang the lamina from the point A. Draw the vertical line A'. It passes through center of gravity. Now hang the lamina from pivot B and draw the vertical line B'. Similarly, hang it from pivot C and draw the vertical line C'. We observe that the 3 vertical lines intersect at a common point G. This common point G is the center of gravity of the irregular shaped lamina. As the body is small, so the value of G for all the particles is same, and hence the center of mass coincides with its center of gravity.